Okay, welcome back, ladies and gentlemen. This unit is about solutions and water. Last class we talked about water already, just some properties of water. Remember, you need to know some vocabulary words. Cohesion, adhesion, surface tension, and a few others, okay? You get your water notes online. Take water notes, take Cornell water notes. In the packet, I gave some Cornell papers for you. Take water notes. The slides are online. Just stop from slides 1 through 12. Okay, slides 1 through 12. Just get the vocabulary words down. Understand those water properties there. Okay, and we'll go on to what today is solubility curve. So when we talk about water, water is really nice. One of the facts about water is that it is the universal solvent. That means it dissolves a lot of other things. Dissolves other things. Many other things. So it can dissolve things. Okay? So water is a universal solvent. Dissolves other things. And so how do things dissolve in water, or different things dissolve in water differently? Okay? When we talk about dissolving, there are three words here that we need to define first. Saturated means that it's the maximum amount of solute dissolved the maximum amount of solute dissolved at a specific temperature. So that means this is the most that it can dissolve. Once you have a cup of whatever it is of water like this, okay, and you put sugar in and you don't see sugar anymore, that means it's dissolved. Then you put more in, it keeps dissolving, keeps dissolving, keeps dissolving. There's going to be a point where it does not dissolve anymore. When it does not dissolve anymore. Okay? And that is when it is saturation. So when it can still dissolve, it's less than unsaturated, means it's less than the maximum amount that can dissolve at a specific temperature. All in plain language, all this means is you can still dissolve more. Okay? Can dissolve some more. Some more what? Some more solute. Okay? And maybe we haven't gone over that. That's a part of your water notes there. A solute is whichever powder, whichever salt that we want to, the things that gets dissolved. The thing is not a good word. The substance that gets dissolved. Alright, substance that gets dissolved is the solute. The solvent is the water itself. The liquid or the medium in which they dissolve the solute. Supersaturated is a solution that contains more solute dissolved than ordinarily. Ordinarily, the maximum is saturated, but how can you get more than the maximum, right? And so the how I'll talk about later. But supersaturated means that more solute dissolved than possible at that temperature. More solute I don't know how to word this. More solute dissolved than typically possible at that temperature, at a specific temperature. And how do you accomplish this? One, you can heat it up. As you heat up, you dissolve it. You can heat. Or you want more solute than solvent, you can evaporate the solvent, the liquid. Okay, and so when you do this, this is a temporary No, supersaturated is temporary because it's that period of time when it's still dissolved, but a moment later it will recrystallize because the temperature cannot keep it supersaturated. It'll bring it back to saturation. Everything is going to bring back to saturation to the maximum. So as it does that, what's going to happen is it's going to crystallize when it cools down. Okay, crystallize when cool down. Crystallize means it's going to form solids. You see some solid or precipitate. Okay, or it could just settle out. So these are some words that you see: settle out. It'll settle out. Some solids will settle out to the bottom, and that's from. It doesn't have to be super saturated, but anytime you cool down a solution, if you cool it down enough, and if it's saturated or super saturated, you can get the solids back. Okay, so since this is about the lab, we didn't do the lab. We'll skip number 1 through 6. So this part is reading the graph. Okay, a little bit of notes here. Tells you this is the line of saturation. Anything on this line means it's saturated. All right. So on line means saturated. Under the line means unsaturated. Over the line equals supersaturated. Alright, those are 3 things you have to remember. If the point's on the line, saturated. Point's on the line, saturated. And here's the other line dot here. It's over the line. That means right here. You compare it to wherever, vertically, wherever it's at. Okay, you compare it with the line at that temperature. The temperature's down here. This is 20 degrees. You have to look at both points 20 degrees. The line is below, the dot is above, so this point, the dot is supersaturated. And then over here on the right side, this orange dot right here, you see that it's clearly below the line where it's at. So that's unsaturated. Okay? So it's pretty simple there as far as seeing where they are. But how do you do them? And there are problems here. I'm going to do 1 or 2 from each section, and you are expected to do the rest on your own. Okay? I will have these answers posted somewhere sometime soon. So number 7, which is reading these graphs. All right. How many grams of solute are required to saturate 100 grams of water? Saturate means you're going to find it on that line in 100 grams of water. This 100 grams of water is right here. That's what it's saying. All this is dissolved in 100 grams of water. So at 80 degrees Celsius, KCl. So you go to 80 degrees Celsius, which is right here. Go up to KCl, is right there. Okay? So what is that? Well, how much is that? Now we go over it and see at 80 degrees how much is dissolved. It's slightly above 50, so it is actually 51 grams of KCl will dissolve at 80 degrees Celsius. That's what it's saying. There's a lot of lines here, but each question only asks you to focus on 1 or 2 lines. And just focus on the line, ignore everything else. See that KCl is at that line right there. Alright. Number B, KClO3 at 90 degrees. 90 degrees, go to 90 degrees, which is right there. Go up KClO3. This is the KClO3 line. It's slightly above that. Slightly above that line too. It's right there, right above that 51, 52. So I'll say 52 grams of KCl. So you estimate between there. If you say 52 and I say 51 or I say 50, it's good enough. Between 1 or 2, because these scales are not really not that big here. The picture is kind of small for you to estimate. So if your estimation is near the ballpark, between 1 and 2 off, that's perfectly fine. But if you say like 55, that's clearly not in the middle. So I'm going to mark that off for that. Okay. So that's 7. Do C, do D, and do E there. Number 8. What is each solution below? What is it? Saturated, unsaturated, or supersaturated? So this is where you can compare. Is it on the line, under the line, or over the line? All right. if it's asking for saturated, supersaturated, and all that. So, so what you do is you have the temperature. I'm going to use a different color so it's easier to see. Let's do purple. 50 degrees Celsius. Go to 50 degrees Celsius. It says 40 grams. Go up, put a dot at 40 grams right there. And then it says 50 grams of what specifically? NaCl. So I compare it to the line NaCl right there. So is that dot on the line, over the line, or under the line? It is over the line, so it is supersaturated. Okay? You write out the word. Don't write letters like this. Supersaturated. Write out. Get used to it. You need to know the words. So do A, B, C, D, E. If you have any questions on any of these sections, please come by it. It should take a couple minutes, 1 or 2 minutes for me to explain it again to you, and you should be fine. You should be on your way. All right, the next page, number 9. Okay, I have these separate ones printed out so that you don't have to flip your page back and forth here. And this graph's slightly too big for this page, but okay, it'll work. All right, number 9. I want to make a few changes here because notice 80 degrees. KNO3, the line for KNO3 is off the chart. So we're going to change 80 degrees from A to 70 degrees. And then D, 70 degrees. And then, yeah. So that's that. How many grams of KNO3 per 100 grams of water? So you have to always make sure that they tell you that it's in 100 grams of water. Because if they double the water, everything doubles. Except the temperature. I mean, the amount of salt doubles. Okay? If they cut the water in half, then the amount of salt is cut in half. If they quadruple the amount of water dissolved in, that means you can dissolve 4 times as much. Okay? It could be complicated, but I'll explain that again later. 70 degrees to 20 degrees. How many grams of KNO3 per 100 grams of water would be crystallized? That means it cools down and it's going to settle down into solids from a saturated solution as the temperature drops. Saturated. So it tells you it's from a saturated solution. So it is along this line of KNO3. Alright. So to figure out saturation, you look at the two temperature. At 70 degrees, it's right there. Slightly above half, so I'm just going to say 136 grams. Okay? At 70 degrees, that's 136 grams will dissolve. Okay? Then now go to 20 degrees. 20 degrees, go up right there. It's slightly below the half midway point, so I'm going to say 34 grams will dissolve there. So this is 34 grams. Again, if you say 135 and you say 33 instead of 136 and 34, that's perfectly fine. We're only 1 or 2 off. It's okay. We both estimated anyways. So, is anybody more right? Yes, I'm always more right, but that's okay. That's okay. Yeah. All right. So, since at 20 degrees, only 34 will dissolve, what happens to the rest? The rest of them crystallize. And how much crystallize? What you do is you subtract them to see how much you crystallize. Okay, so it's 102 grams will crystallize. Grams of KNO3 will crystallize. Right? So basically, it's the difference between these 2 points that's going to crystallize. It's going to drop. This gets undissolved. Basically, crystallize means it undissolves. The temperature cannot keep it dissolved. It's not warm enough. It has to be hotter for it to stay dissolved. Okay? So you do the same thing there for B, C, D, and E. Oh, this is going a little too long here. 15 minutes already. I've got to pick up the pace here. All right, number 10. How many additional grams of NaNO3 are required to keep the solution saturated during the temperature changes? This is, again, it didn't tell you, but in 100 grams of water still. Oh, it does. No, never mind. Never mind, I take that back. It tells you on each question how much water. It tells you on each question how much water. So, how much additional NaNO3? So now you're going up, okay? As you cool down, it will settle out. As you increase temperature, As you increase temperature, you can dissolve some more. So the question they're asking is, how much more can you dissolve? So number A here, it says from 10 to 30 degrees. Actually, I'm going to do C and D, because there's a problem with C and D. Okay, C, 100 grams of water. The temperature changed from 40 to 90. We have a problem here because we're talking about NaNO3. We're only talking about this line up here. Notice it doesn't go to 90. So let's change that to 80. Let's change that to 80. Okay, change both those to 80. My fault. I didn't change the number appropriately. Okay. So 40 to 80. So we'll circle those two temperatures there. We'll go up to NaNO3. NaNO3. That point right there, it's about 148. Okay. And then at 40, we go up to 40 right there. That looks like it's right in the middle, so I'd say that's 105. So how much more can I increase to go from here to there? Because I can dissolve that much. Basically, you subtract again. So 148 minus 105 is, so to go from 105 to 148, we need 143. Oh no, you need to add 43 grams, right? We can add 43 more grams. All right. So what happens in D here, the difference in D is now it's 100 grams of water. 1,000 grams of water, sorry. It's 10 times as much water. 10 times. Correct? 1,000 grams is 10 times more than 100. And so whatever the value is, it's going to multiply by 10. So this multiplied by 10 is 1050. You just add a 0 at the end. 1480. And you subtract that, you actually get 430 grams. You can add 430 grams, 10 times that's more. Okay? So the point is trying to make here is that if you change the amount of water, then this graph, remember this graph tells you everything's in 100 grams of water. So if we double the water, we double the amount of solute can dissolve. If we put 1,000, which is 10 times more water, then we can dissolve 10 times more of the powder, whatever it is. Okay. And just a quick reminder here, for water, the density is equal to 1 grams per milliliter. So grams and milliliter are the same thing for water. Okay. And 1 liter is equal to 1,000 milliliter, which is equal to 1,000 grams. For water only, because that's the density of water. Different things will have different densities. Okay. And for 11, what you do is you look at these two, you see where they cross. For example, the graph is like that. And if they have the same solubility, that means they cross there, go down and look at the temperature. This is 70 degrees. Then they both, it's 35 degrees, whatever, just midway. So that is the temperature at which they have this equally soluble. That means they can dissolve that much water. Okay. And so go ahead and answer these questions to the best of your ability. We'll actually go over these questions in class, so no worries. That's a lot. Have fun. If you need any help, always stop by and ask me a question or two. Ask me to show you how to do this. And it's fairly simple. This video is a little longer because I have to explain it slowly. I don't know if I went slow, but I just have to explain it in a lot of details. Goodbye.